Did you try solving the problem which I gave you in last class? Are you able to view the screen, everyone?
Yes, ma'am.
Yes,
Did
ma'am.
you try this problem? Did you guys try this problem? Yes or no? Did you try or not? You didn't try? Okay, we'll try solving this problem. So you have a given differential equation with the initial conditions. I had told you to solve the first part of the question, right? Total response. So first we have to find the characteristic equation from the given differential equation. So the characteristic equation is s square plus 4s plus 4, which is equal to 0. What are the roots of the characteristic equation? -2 and -2 you will get. Okay. So the roots of the characteristic equation are -2 and -2. So they are repeated roots. So if you have repeated roots, what you have to do is, so your natural response will be of this form. Yn of t will be k1 plus k2 into e power -2t. Got it? For t greater than or equal to 0. Understood, everyone? So now you have to make use of the given initial conditions and you have to find what is k1 and k2. Okay, so try finding k1 and k2. So the roots of the characteristic equation are real and repeated. So it's of the form r to the power of p plus 1. So you will have e power rt into k naught plus k1 into t plus k2 into t square, so on up to kp into t power p. Okay, we have seen in that classification, right? So in the tabular column we have seen these. How will the structure of your natural response be? So this is a structure of natural response because you have repeated roots. Okay, so k2 into t, I'm sorry. Now try finding what is k1 and k2. Okay, so how do you find k1 and k2? We'll make use of these initial conditions and we'll find k1 and k2. Okay, try finding that k1 and k2. If yn of, if you substitute t is equal to 0 in this natural response equation, so you get k1 is equal to 0, right? So if we'll differentiate that yn dash of t. So if you do like that, you will have so you have minus 2 k1 plus k2 of k2 into 1 into e power -2t, right? So if you multiply, you have -2 k1 -2 k2 into e power -2t. Yes or no?
Yes, ma'am.
So what is k2? What is k2? So if t is equal to 0, yn dash of 0, if you substitute t is equal to 0 in this equation, yn dash of t, so you have -2 k1 plus k2 . is equal to 1, right? So what is K2? What did you get K2? K1 is 0, so K2 will be equal to 1. Okay. So now we have got,
Ma'am,
yes,
ma'am, differentiation is correct, ma'am. Y and dash of t, ma'am.
just a minute, minus 2 into K1 plus K2 into 1 into e power minus 2t.
No, ma'am. UV rule. We have to use UV rule, no, ma'am.
Yes,
We have to use UV rule, no, ma'am, for differentiation here.
yes, you have t into e power minus 2t. Yes, try doing that. So if you do that, if you use UV rule, you'll get the same.
No, ma'am. I will get k equals 2, ma'am. K2 equals.
You will get 1. Check that.
Okay, ma'am.
How much will you get K2? So we have minus 2 K1, minus 2 K1, just a minute. Yeah, if we substitute t is equal to 0 in this natural response, you will get K1 is equal to 0. Correct? Because if we put t is equal to 0, we'll get K1 as 0. If we differentiate this, what do we get? So you have K1 into e power minus 2t plus K2 into t into e power minus 2t. So this is yn of t. You try differentiating this. What do you get if you differentiate this? Minus 2 into K1 into e power minus 2t plus K2 into t, if you keep t constant, you have minus 2 into e power minus 2t plus e power minus 2t into t. Correct?
Yes, ma'am.
So now you solve it. So,
Ma'am, e power minus 2 into 1, right, ma'am?
t, yeah, it's 1. We are keeping t constant and differentiating e power minus 2t. Then e power minus 2t will keep constant and will differentiate t, we get 1. Now you find out K2. You try to get an equation. So minus 2 K1 into e power minus 2t plus K2 into t into minus 2 into e power minus 2t plus K2 into e power minus 2t. So if you substitute t is equal to 0 in this equation, you will get minus 2 K1 plus this will be 0 plus K2, correct, is equal to 0. Got it, everyone? Clear? At least respond now. Why you people are silent?
Yes, ma'am.
It is correct now. So if K1 will be equal to 0, so K2 will be equal to,
Ma'am, y dash of n is 2, ma'am, at t equal to 0. Initial conditions.
1, ma'am, you have given.
it is 1 or 2, 1 minute. Oh yeah, I forgot to take that. It is equal to 2. Okay. So what do you get? No, it is 1, right? I have given 1 or
For
2.
part B, you have given 2, ma'am.
Okay. It is 1, I think.
Yes, ma'am. 1.
It is 1. So you get K2 is equal to 1. Correct? This becomes 0. K1 is 0. K2 is equal to 1. Got it, everyone? Y dash of 0 is equal to 1 for first case. I forgot to take this. I'm sorry. Got it?
Yes, ma'am.
So now we have
Yes, ma'am.
got K1 0, K2 1. So what will be your natural response, Yn of t? So it will be t into e power minus 2t for t greater than or equal to 0. Got it, everyone? Is it clear?
Yes, ma'am.
Yes, ma'am.
Now natural response is done. So now you try to find a particular response. Okay. So particular response makes use of input signal x of t. So what is the given input signal? So in the question, the given input signal is 2 into e power minus 2t into u of t. So you have 2 into e power minus 2t into u of t. Okay, this is the given input signal, and the roots of the characteristic equation are minus 2 and minus 2. Okay, so what is the particular response, yp of t? What is yp of t? What is yp of t? It will be t square into c into e power minus 2t. Got it, everyone? Clear?
Yes, ma'am.
So yp of t is t square into c into e power minus 2t because we have repeated roots here and this is the input signal. Okay, so now we'll try to write the differential equation in terms of the particular equation. Okay, particular response. So yp double dash of t plus 4 times yp dash of t plus 4 yp of t is equal to 2 into e power minus 2t. So we have got the equation. Now we'll try to find what is the yp dash of t and what is yp double dash of t. So yp of t is t square into c into e power minus 2t. So yp dash of t would be equal to product rule, you have to use it. C I will take outside, t square into e power minus 2t you have. So that would be equal to c, so t square I'll take constant, I have minus 2 into e power minus 2t plus e power minus 2t and I'll differentiate t square, you get 2t. Got it, everyone? So yp dash of t would be equal to minus 2c t square into e power minus 2t plus 2c into t into e power minus 2t. Got it? Clear? We are trying to differentiate this for getting yp dash of t. Okay, so you have t square and e power minus 2t. Product rule we can use. Keep this constant, differentiate this, then keep this constant and differentiate this. Keep this constant and differentiate this. Got it? Clear? So now you find yp double dash of t. So yp double dash of t means you have to differentiate this signal once again. Okay, so what do you get? So minus 2c I will take outside. So you have, I have product rule again. Okay, t square, I'll keep constant. So you have e power minus 2t into minus 2. Correct? Yeah, e power minus 2t into minus 2 plus e power minus 2t into 2t. Okay, I've used product rule for this. Plus, if I take 2c common here, okay, I'll take 2c out. So you have a product rule here, t into e power minus 2t. So if you keep t constant and if you differentiate e power minus 2t, you'll have e power minus 2 into e power minus 2t plus keep e power minus 2t constant and differentiate t, you will get 1. Clear?
Yes, ma'am.
Others clear, everyone? It is clear or not?
Yes, ma'am.
So yp double dash of t would be, I'll solve this first. You have minus 2 t square into e power minus 2t plus 2t into e power minus 2t. Okay, plus 2c into minus 2t into e power minus 2t plus e power minus 2t. So this is your yp double dash of t. Okay, I can do one step more. So you have 4c t square into e power minus 2t minus 4c t into e power minus 2t minus 4c t into e power minus 2t plus 2c into e power minus 2t. Got it, everyone? Yp double dash of t. Clear? So now we have what is yp of t. So yp of t is t square into c into e power minus 2t. Then we have what is yp dash of t. It's minus 2c into t square into e power minus 2t plus 2c into t into e power minus 2t. Then we also have yp double dash of t. Okay, now substitute that these yp dash, yp double dash and yp of t in this equation and try to find what is c. Okay, we have to find this constant c. So try to find at c. Is it clear till here, everyone?
Yes, ma'am.
Okay, so now let us put that in the equation. So we have yp double dash of t plus 4 yp dash of t plus 4 yp of t, which is equal to 2 into e power minus 2t. So you have 4c t square into e power minus 2t minus 4c into t into e power minus 2t minus 4c into t into e power e power minus 2t plus 2c into e power minus 2t. This is yp double dash of t. Now you take plus 4 times yp dash, 4 into minus 2c t square into e power minus 2t plus 2c into t into e power minus 2t plus you have yp dash of t, 4 times yp dash, right? So 4 into t square into c into e power minus 2t, which is equal to 2 into e power minus 2t. So try solving this. Few terms will get cancelled. Try solving this.
Ma'am, in yp double dash of t, in between terms are same, no ma'am, we can add up
Yeah.
second and third term.
Yeah, 4c t into e power minus 2t, yes. So if you solve it, you have 4c t square into e power minus 2t plus 4c t into e power minus 2t plus, sorry, minus no, minus 4c t into e power minus 2t plus 2c into e power minus 2t minus 8c t square into e power minus 2t plus 8ct into e power minus 2t plus 4t square 4c t square into e power minus 2t, which is equal to 2 into e power minus 2t. So what all terms will cancel? 4c t square, 4c t square, 8c t square, plus minus. Okay, then what will get cancelled? Here you have 4c t into e power minus 2t. Yeah, these two will get cancelled. So what are you left with? you have 2c into e power minus 2t is equal to 2 into e power minus 2t. So c is equal to 1. Clear? So your particular response yp of t will be t square into e power minus 2t for t greater than or equal to 0. Got it, everyone? Particular response understood? This is quite lengthy problem. Got it?
Yes, ma'am.
What about others? Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So now let us see what is forced response. So forced response yf of t is natural response plus particular response. So our natural response of this was this form k1 plus k2t into e power minus 2t, and this is t square into e power minus 2t yp of t. So now we have to find the constants k1 and k2 by making use of the zero initial conditions. So this is yf of t. So now you substitute t is equal to 0 in this. So yf of 0 would be equal to, if you substitute t is equal to 0, you will get k1 is equal to 0, right? This is equation 3 you can take. So next, if you substitute, if you differentiate yf dash of t, what will you get? So this is product rule you do. So we have k1 plus k2t into minus 2 into e power minus 2t correct, plus e power minus 2t into k2. Okay, and we have t square into e power minus 2t, that also you use product rule, plus you have t square into minus 2 into e power minus 2t plus e power minus 2t into 2t. Now you put t is equal to 0. Okay, try to get an equation first. So we'll try solving this. Minus 2 k1 into e power minus 2t minus 2 k2 t into e power minus 2t plus k2 into e power minus 2t minus 2t square into e power minus 2t plus 2t into e power minus 2t. Got it, everyone? Yf dash of t. Clear? We have used product rule for this as well as this. Okay, first I'm keeping this constant and I'm differentiating this. I get minus 2 into e power minus 2t if I differentiate this. Plus I'll keep this constant and if we differentiate this means we get k2. Okay, if we differentiate this equation. Next, if you, this is also product rule. So you have t square into minus 2 into e power, keep this constant, differentiate this. Then you differentiate this and keep this constant and write the equation. Now you put t is equal to 0 in this, yf dash of 0. So what do you get? We are assuming zero initial conditions here. So what will you get? If t is equal to 0 in this equation, wherever you have multiplication of t, that terms will go. This will become 0, this will be 0, this will be 0. So you are left with minus 2k2 plus, sorry, minus 2k1 plus k2 is equal to 0. So what do you get? If k1 is 0, k2 is also equal to 0. Got it? Clear, everyone?
Yes, ma'am.
Others clear?
Yes, ma'am.
So
Ma'am,
now,
shouldn't it be 1, ma'am?
what?
Y dash of 0 is 1, no, ma'am.
No, while we are finding the forced response, you have to assume zero initial conditions, right?
Oh, so everything you should take it as 0, ma'am.
Yes,
You should take everything as 0, not the one which is mentioned in the question.
you have to equate it to 0. We are doing first part only still.
Okay.
Okay, when you're finding forced response, that time K1 and K2 you have to assume 0 initial conditions. When you're finding this particular response, sorry, which is that? When you're finding that natural response, that time you have to assume initial conditions. Got it?
Okay, ma'am.
Okay. So now you have got what is K1 and K2 in this. So K1 is also 0, K2 is also 0. So your equation would be yf of t will be equal to, so what was that yf of t? It was equal to this plus this, natural response plus particular response. This natural response is 0 because k1 and k2 is 0. This whole term will be 0. You're left with t square into e power minus 2t. Okay. So we are left with t square into e power minus 2t. So your total response y of t would be equal to natural response plus forced response. What was the natural response we got? What is the natural response we got at the beginning? T into e power minus 2t we have got, right? T into e power minus 2t. Then you add this term of particular response, what we have got, of forced response. So it was t into e power minus 2t plus you have t square into e power minus 2t. Got it, everyone? Total response of the system. Is it clear? It's clear or not?
Yes.
Yes, ma'am.
So if a question is given with two roots, repeated roots, you have to solve like this. So now they have given a sub question also in the question, right? So the sub question what they have given is, they're telling you to find the total response if part B. So they're telling you to find the total response y of t if x of t is the same. Okay, it is 2 into e power minus 2t into u of t. So for this y of t, you write into u of t at the end, or t greater than or equal to 0 you have to write, because we have multiplication of u of t. So the part B is you have to find the total response if input is x of t, it's the same as part A. But initial conditions they have changed. Y of 0 is equal to 0 and y dash of 0 is equal to 2 they have given. So input is same as part A, input signal, but the initial conditions are doubled. Okay. So if initial conditions are doubled, then the principle of superposition will hold good for natural response. So natural response should be doubled. So that you get y of t is equal to 2 times yn of t plus yf of t. So that would be 2t square into natural response is 2t, right? So 2t. 2 times t into e power minus 2t plus t square into e power minus 2t. Got it, everyone? Part B. They have just, the input signal they have given is the same, but the initial conditions are doubled. So you double the natural response. Okay, so it will be 2 times whatever you have got. Next case, part C, they have given the initial condition same as part A. Okay, so you have to find y of t if the input signal is 4 into e power minus 2t into u of t. If x of t is equal to 4 into e power minus 2t into u of t. Okay, and the initial conditions are same. Y of 0 is 0 and y dash of 0 is 1. So now what you will do? If input is doubled, the forced response will be doubled. So y of t is equal to yn of t plus 2 times yf of t. Okay, so it's t into e power minus 2t plus 2t square into e power minus 2t. Got it, everyone? Clear? Is it clear?
Yes, ma'am.
Others, is it clear, this problem?
Ma'am, in first sub question, ma'am, y f dash of 0 should be 1 only, ma'am. Because initial conditions they have given, it's 1, ma'am.
This y dash of 0. In
Yes, ma'am.
sub-question B, they have given, I have given y dash of 0 as 2. Observe properly.
No, ma'am, in A question.
In A question, it is 1 only.
Yes, ma'am, you took 0, ma'am.
Where?
There K2 is equal to 0.
Wait. See, this is forced response, right?
Yes,
When
ma'am.
will you use the initial conditions? While finding natural response. When you're finding forced response, assume 0 initial conditions. Okay?
Then it
That
will
is,
be 0 only, ma'am.
you equate it to 0. Yf dash of 0 equated to 0. Yf of 0 also equated to 0. That is what we have seen in all the problems right till now.
Yes,
First,
ma'am.
when you are taking natural response, you will put initial conditions, whatever is given in the problem, right? While you are calculating the forced response, again you are calculating K1 and K2, correct? That time you will have to assume 0 initial conditions.
Okay, ma'am.
That is what we have done in all the problems till now. Okay.
Ma'am, if y of 0 is any value, what should we do?
Which one?
If y of 0 is some value.
Y of 0 is equal to some value. You put that value in that when you are finding the natural response. If you are telling y of 0 is equal to some value, when you are equating this yn of t, if you are putting t is equal to 0, that time equate that value to this when you are putting t is equal to 0. Got it?
Yes.
So whatever initial conditions they have given, that you are using only when you are finding natural response. When you are finding forced response, again you are finding K1, K2, that time assume 0 initial conditions. Okay? You can observe in the problems which we have solved. While taking forced response, always you have to assume 0 initial conditions. Got it, everyone? Is it clear?
Yes, ma'am.
Okay, this is all about differential equations. I have solved all the problems from textbook because all are different. So I wanted you people to solve all. So now we'll try to find the difference equation, solution to differential equations.
Ma'am,
Yes?
just a minute. Can you scroll up to C part, ma'am?
Yeah. Which part you wanted?
C part, ma'am.
Yeah.
Yes.
So this difference equation is same as differential equations. Okay. So there we took differential equations, right? Nth order differential equations. So here we'll take difference equations with a single input. So you consider an nth order difference equation with single input. So y of n plus a1 into y of n minus 1. So for plus a2 into y of n minus 2. So on up to an into y of n minus capital N, which is equal to single input x of n. So this difference equation is for discrete time signals. Differential is for continuous time signals. So we have seen how to represent the LTI system, right? First method was we represent by impulse response, then block diagram method, that is direct form 1, direct form 2. This is third method, difference and differential equations. Differential equations are for continuous time signals and difference equation is for discrete time signals. Fine. So what is the solution of this equation, difference equation? The solution of this difference equation is the sum of natural response as well as forced response. Okay, when the initial conditions are given. So the initial conditions will be of this form: y of minus 1, y of minus 2, up to y of minus n. Fine. So you have to find the characteristic equation of the given above difference equation. So that would be 1 plus a1 into z inverse plus, I'm taking some variable z, okay. So you have a2 into z power minus 2, so on up to an into z power minus n, which is equal to 0. So if you multiply this whole equation by z power n, so you will have z power n plus a1 into z power n minus 1 plus a2 into z power n minus 2, so on up to a to the power of n, which is equal to 0. So the characteristic equation has n roots. Okay, you have to find the characteristic equation, that will be z1, z2, z3, so on up to z to the power of n. Okay, so if your characteristic equation is real and distinct, so you will have the input, so you will have natural response of this form, yn of n is equal to k1 into z1 to the power of n plus k2 into z2 to the power of n, so on. Okay, up to kn into zn to the power of n. Fine. So I will write a table for the roots of the characteristic equation and the structure of natural response. You observe that. So roots of characteristic equation and structure of structure of natural response. Okay, so if your roots are real and distinct, so you have k into r to the power of n. Then if your roots are complex and conjugate or complex conjugate, you have r into e power j omega. So that will be r to the power of n into k1 cos omega n plus k2 sin omega n. Okay, then if you have real and repeated, so that would be of the form r to the power of p plus 1. So you have r to the power of n, k naught plus k1 into n plus k2 into n square up to kp into n to the power of p, if they are real and repeated. Okay, so that is about natural response. Next, we have to find the particular response as we have done for the previous. So particular response has same form as the input, right? So you have to take the input and depending on that you will have particular response. So I'll write a table of input signals and form of particular response. So first, if your input signal is some constant, so your particular response will be another constant, C1, okay? Then if your input signal is alpha to the power of n, then particular response will be C into alpha to the power of n. Next you have cos n omega plus beta, as if you have this as your input signal, then particular response structure will be C1 cos n omega plus C2 sin n omega. Next, if your input signal is alpha to the power of n into cos n omega plus beta, then your particular response will be of the form alpha to the power of n C1 cos n omega plus C2 sin n omega. These things are all there in textbook. I am doing the same. Okay. So if your input signal is of the form n, so particular response will be of the form C0 plus C1 into n. Okay. It is same as our differential. Then if you have n to the power of p, so that particular response structure will be C0 plus C1 into n plus C2 into n square up to Cp into n power p. It is like t power p in differential. Next, if you have n into alpha to the power of n, so your particular structure will be alpha to the power of n into C0 plus C1 into n. Then if you have n to the power of p into alpha to the power of n, it will be the same thing multiplied with alpha to the power of n. So that it will be alpha to the power of n into C0 plus C1 into n plus C2 into n square up to Cp into n power 2. So these are input signal and particular responses. Okay. So now we shall see, we have seen what is particular response. So forced response will be yf of n, which is equal to yn of y capital N of n plus y p of n. Okay, that is natural response plus forced response. Okay, so the constants present in this forced response, that is we had k1 and k2 previously, right? So here also you have k1 and k2, that will be solved or found, evaluated by you assuming zero initial conditions. Okay, while you are finding the forced response, again you have to find the constants k1 and k2, that you will find by assuming zero initial conditions. Okay, so after finding the forced response, y of t, that is total response, y of n, is equal to yn of n natural response plus yf of n, that is forced response. Okay, quickly I'll give you one problem, we'll try to solve that. So find the total response of the system described by the difference equation. So y of n plus 4 times y of n minus 1 plus 3 times y of n minus 2 is equal to u of n. This is the given difference equation for you. With initial conditions, y of minus 1 is equal to 0 and y of minus 2 is equal to 1. This is the given difference equation along with the initial conditions. Okay, it is, everything is same as differential. Okay, just you have t replaced by n, that's all. This is difference equation, that is differential equation. So the characteristic equation is 1 plus 4 z inverse plus 3 z bar minus 2 is equal to 0. So now multiply this equation with z square. Okay, so you have z square plus 4z plus 3 is equal to 0. Now you find the roots of the characteristic equation. What are the roots? What are the roots?
Minus 3, minus 1.
You get z is equal to minus 3 and minus 1. So your natural response yn of n will be equal to k1 into minus 3 to the power of n plus k2 into minus 1 to the power of n. Okay. So it was of the form k1 into z1 to the power of n plus k2 into z2 to the power of n, right? So we have got our z1 and z2 as minus 3 and minus 1. So if you put that minus 3 and minus 1 in the form, in place of z, you have k1 into minus 3 to the power of n plus k2 into minus 1 to the power of n. And they have given you the initial conditions as y of minus 1 0, y of minus 2 1. So in this yn of n, if you substitute n is equal to minus 1, what will you get? In previous differential we were putting t is equal to 0, right? Here you have to put n is equal to minus 1 and n is equal to minus 2. So yn of minus 1 would be equal to k1 into minus 3 to the power of minus 1 plus k2 into minus 1 to the power of minus 1. Okay, this is your equation 1. And yn of minus 2 is equal to, so this equation is equal to 0, right? And this equation is equal to 1. So this will be equal to k1 into minus 3 to the power of minus 2 plus k2 into minus 1 to the power of minus 2. This is your equation 2. Now try solving this. Equate first equation to 0 and second equation to 1, because that is the initial conditions for the problem.
Ma'am, why did we take minus 2, ma'am?
That is initial conditions for difference equation. Y of minus 1 is equal to 0, y of minus 2 is equal to 1. In difference equations, initial conditions will be like this. There you have y of 0 and y dash of 0, right? Here you have y of minus 1 and y of minus 2.
Okay, ma'am.
Okay, now solve this. Equate first equation to 0 and second equation to 1 and find out K1, K2, which is equal to 0, which is equal to 1. And tell me what is K1 and what is K2. You can solve it in Calc. Yes, guys. What is K1, K2?
9 by 2 minus 3 by 2.
What is 9 by 2? Minus 4.5 and 3 by 2 is 1.5. So your natural response yn of t will be equal to
K1 is
it
positive,
is
negative.
how much you got? Minus 4.5, 1.5 you have to get.
Ma'am, I got K1 as 9 by 2, K2 as minus 3 by 2.
Check once. Have you taken this properly? Minus of 1 by 3. This is 1. Have you got minus 4.5 everyone?
Ma'am, minus 4.5.
Minus 1.5 and 4.5, ma'am.
Check once. You have to get minus
Excuse me,
4.5.
ma'am. Ma'am,
Yes, ma'am, same, ma'am.
Yes.
ma'am, Shaila ma'am is asking if you could exchange today's class with Wednesday's class, ma'am. Like you can take till 1 o'clock today, and then your class she will take on Wednesday.
When I can take this class, I can take her class, but giving my class is difficult because I have to complete the portions.
Okay, ma'am. I'll ask her because today she can't take class. That's what she's
I
telling.
will extend this class, okay?
Okay.
We'll solve the difference equation and we'll complete that. I will take ma'am's class, you tell her.
Okay, ma'am. I'll tell her.
Yeah. So did you all get this? Minus 4.5, 1.5? Substitute the values correctly. This is equated to 0, this is equated to 1. Are you guys solving?
Yes, ma'am. Again, I got plus 4.5 and minus 1.5.
Yes, ma'am.
Check once, but it is given minus 4.5 in the textbook.
Ma'am, in equation 2, K2 will be negative or positive, ma'am?
K2. You have minus 1 by 2 square, correct?
It is 1
So
by
it will
minus
be-
1
Minus
whole
4.5 and 1.5.
This is minus 1 by 2 square, correct? Did you guys get this one? K1, K2?
Oh my God.
Yes, ma'am, I got.
Others? You do it, okay, you will get it minus 4.5, 1.5. Then we have natural response which is equal to minus 4.5 into minus 3 to the power of n plus 1.5 into minus 1 to the power of n. This is your natural response. Got it everyone? Is it clear? Vinamrata, did you inform ma'am that I'll continue?
Yes, ma'am.
What ma'am told?
Okay, she'll take tomorrow her class. That's all. She didn't tell anything else.
Okay, fine. Yes, guys, did you solve this? Sorry, did you understand this?
Yes, ma'am.
So now we'll see what is particular response. So particular response will depend on the input signal x of n, right? But x of n given in the question is u of n, right? What is u of n? It is some constant, right? If your input is some constant, the structure of particular response will be another constant, that is C1. So yp of n would be equal to C. Okay. So we'll find out C by substituting the particular response in the difference equation. Okay, so that will be yp of n plus 4 yp of n minus 1 plus 3 yp of n minus 2, which is equal to u of n, that is 1. Okay, so yp of n is C. Okay, so yp of n minus 1 would be equal to also C only. Okay, and yp of n minus 2 also will be equal to C only. So we have C plus 4C, because we don't have n here, right? If you have any n variable, you can substitute n minus 1, but you just have a constant, so it is equal to a constant only. Okay, so you have C plus 4C plus 3C is equal to 1. So you have 8C is equal to 1, C is equal to 1 by 8. Got it, everyone? Clear? So your yp of n will be equal to 1 by 8. Is it clear? Yp of n is equal to 1 by 8. Got it?
Yes, ma'am.
So now we have to find the forced response. So forced response yf of n is the summation of natural response plus particular response yp of n. Natural response we have k1 into minus 3 to the power of n plus k2 into minus 1 to the power of n plus 1 by 8. Okay, now you have to find the constants k1 and k2 by assuming zero initial conditions. You have to equate it to 0. Okay, so this is yf of n. So yf of n minus 1 would be, yf of minus 1 would be when you substitute n is equal to minus 1 in this equation. Okay, so you have k1 into minus 3 to the power of minus 1 plus k2 into minus 1 to the power of minus 1 plus 1 by 8. Okay, which is equal to 0, equated to 0. Then you take yf of minus 2. So if you take yf of minus 2, wherever you have n, replace it with minus 2. Okay, so you have k1 into minus 3 to the power of minus 2 plus k2 into minus 1 to the power of minus 2 plus 1 by 8 is equal to 0. So this is equation 3 and equation 4. So what is this equation 3 and equation 4? We are finding the forced response by assuming zero initial conditions. Okay, so now you find k1 and k2 and tell me what you will get.
Ma'am, for the equation 4, it should be equal to 1, right, ma'am?
No, I'm telling you that only. For forced response, you take zero initial conditions. You take that equal to 1 when you are doing for natural response at the beginning, first step. Okay. Soon after you find the roots of the characteristic equation, you'll find natural response. Now that time you take initial conditions. That time you have to take initial conditions. When you're finding the forced response, assume zero initial conditions and find k1, k2. So what is k1 and k2? Yes.
I got 9 by 8 and minus 1 by 4.
Okay, 9 by 8 is 1.125 And minus 1 by 4 is minus 0.25. Got it, everyone? Did you all get K1, K2?
Yes, ma'am.
Others got it?
Yes, ma'am.
So your YF of n would be equal to 1.125 into minus 3 to the power of n minus 0.25 into minus 1 to the power of n plus 1 by 8. This is your forced response. So now we'll find a total response, that is natural response plus forced response. So y of t is yn of n plus yf of n. Okay. So what is the natural response we got previously? K1, K2?
Ma'am, force response, we should write U of n, ma'am, at the last.
Yeah, we'll write at the last. After adding, we'll write that. Okay. So what did you get? Yn of n. What is the natural response we got? That is minus 4.5 into minus 3 to the power of n plus 1.5 into minus 1 to the power of n. Yes or no?
Yes, ma'am.
So put that in place of natural response, that is minus 4.5 into minus 3 to the power of n plus 1.5 into minus 1 to the power of n plus 1.125 into minus 3 to the power of n minus 0.25 into minus 1 to the power of n plus 1 by 8. This is for t greater than or equal to 0. Okay, you can, if you want, you can write it here also. So, or you can multiply it with u of n. Now, if you possible, you can solve this, right? So, what do you get? So, minus 4.5 plus 1.125, you get minus 3.375 into minus 3 to the power of n plus 1.5 minus 0.5 is 1.25 into minus 1 to the power of n plus 1 by 8 into u of n. Sorry, this is n greater than or equal to 0, not t. Understood? It's clear?
Yes, ma'am.
You want me to explain once again how we have solved this? So I'll brief up once, please listen. The procedure is same. First we have to find natural response, then particular, then forced. When we are finding the natural response, first we get the roots of the characteristic equation. So if the roots are real and distinct, so it will be of this form. Okay. So take that natural response structure will be like this. So assume the initial conditions given in the question and find out K1, K2. First case when you are finding natural response. After finding natural response, you have to find particular response depending on the input signal. If your input signal is a constant, particular response will also be another constant, C. So yp of n is C. So yp of n minus 1 is also C only and yp of n minus 2 is also C only. Now write that particular response in the difference equation. You get 4C plus 4C plus 3C is equal to 1. So find out C. That is your particular response. After finding out that, try finding the forced response. Forced response is a summation of natural response as well as particular response. So by assuming zero initial conditions, when you are finding forced response, assume zero initial conditions. So you find yf of minus 1 and yf of minus 2 by assuming zero initial conditions. Then you find K1, K2. After finding K1, K2, find the total response. Add natural response with forced response. Got it, everyone? It's clear?
Ma'am,
Yes.
ma'am, so in this K1, ma'am, like how we get 9 by 8, ma'am? 1.125.
You have to solve this equation 3 and 4.
Fine.
Okay, you have to solve this. Okay, solve this equation you and find out. You can do that in Calci. I don't. Yeah, in that mode setup, you will do equation form, right? 5
Yes,
and
ma'am.
1. Okay, you solve this equation first, and you take in Calci mode setup. Mode setup, you take equation form. Click on 5.
Yes, ma'am.
Mode setup. 5 you take, that is equation form. Okay, in that you take 1. 1 only, correct? It's 1 only, no? You have 2 unknowns. So you take 1 and you give equations. Got it? You will get K1, K2.
Okay, ma'am.
So after finding K1, K2, put that in this forced response. Then you find a total response. Understood, everyone? Clear?
Yes, ma'am.
Let us take one more problem and solve it. So take down, find the total response. Find the total response for an LTI system described by difference equation. Y of n minus 0.9 into y of n minus 1 plus 0.2 into y of n minus 2, which is equal to 0.5 to the power of n. And the initial conditions are y of minus 1 is equal to 1 and y of minus 2 is equal to minus 4. Okay, this is the given question that they're asking you to find the total response of LTI system. Okay, which is given by this difference equation. So first step is find the characteristic equation. So it is 1 minus 0.9 z inverse plus 0.2 z power minus 2 is equal to 0. Okay, now multiply this equation by z square. You have z square minus 0.9 z plus 0.2 is equal to 0. Now tell me the roots of the characteristic equation. What do you get? So what are the roots of the characteristic equation? Point 0.5 and 0.4. Minus and minus. No, plus. Correct? Z square minus 0.5 z minus 0.4 z. You can do it in Calci or you can do like this also. Plus 0.2 is equal to 0. So z into z minus 0.5 minus 0.4 into z minus just a minute. Z minus half, yeah, z minus 0.5 which is equal to 0. So z minus 0.4 and z minus 0.5 is equal to 0. So you get z as 0.4 and 0.5. Got it, everyone? Z is equal to 0.5 and 0.4. Clear?
Yes, ma'am.
So now what are the roots? You have got the roots 0.5 and 0.4. So natural response yn of n will be equal to k1 into 0.5 to the power of n plus k2 into 0.4 to the power of n. This is the structure of natural response when their roots are real and distinct. Okay. So now you find constants k1 and k2 making use of the initial conditions. That is y of -1 is 1, y of -2 is equal to -4. So give values for this n as -1 and -2 and equate it to 1 and 4 respectively. 1 and -4 respectively. So you have yn of -1 which is equal to k1 into 0.5 to the power of -1 plus k2 into 0.4 to the power of -1 which is equal to 1, and yn of -2 is equal to k2 into 0.5 to the power of -2 plus k2 into 0.4 to the power of -2 which is equal to -4. Solve this equation 1 and 2 and find out k1, k2. What is your k1, k2? How much is k1, k2, guys? Are you people solving?
13 by 2 and minus 24 by
13 by 2, 6.5 and
minus 24 by 5.
4 point, minus 4.8.
Yes, ma'am.
So yn of n is equal to 6.5 into 0.5 to the power of n minus 4.8 into 0.4 to the power of n. Got it, everyone? This is your natural response by assuming the initial conditions, given initial conditions. Now you find the particular response. Particular response just depends on the input signal x of n. So in this question, what is the input signal? It's 0.5 to the power of n. So what form is that? So what is the form of this? What will be the structure of this particular response?
Alpha to the power n, ma'am.
Alpha to the power of n, and also you observe here 0.5 is one of the roots of the characteristic equation, correct? Yes or no?
Yes, ma'am.
So what you will have? 0.5 is one of the roots of the characteristic equation, and you have 0.5 that is alpha to the power of n. So what is your particular response? Yp of n structure. It will be c into n into 0.5 to the power of n. Got it, everyone? If you have just alpha to the power of n, so that will be c into alpha to the power of n. But this 0.5 is one of the root of the characteristic equation, so that you have n here. Understood? Clear? Is it clear, everyone?
Yes, ma'am.
So now we have to find this constant c. So how do we find this constant c? By substituting the particular response in the difference equation. So yp of n minus 0.9 into yp of n minus 1 plus 0.2 into yp of n minus 2 is equal to 0.5 to the power of n. So now we have to find yp of n minus 1 and yp of n minus 2 and put that in this equation. So yp of n was C into n into 0.5 to the power of n. So yp of n minus 1 would be equal to C into n minus 1 into 0.5 to the power of n minus 1. Okay. And yp of n minus 2 would be C into n minus 2 into 0.5 to the power of n minus 2. Got it? Clear? So after getting this, just we are putting n in place of n minus 1 and n minus 2. So now put that in this equation. So in the difference equation, you have C into n into 0.5 to the power of n minus 0.9 into C into n minus 1 into 0.5 to the power of n minus 1 plus you have 0.2 into C into n minus 2 into 0.5 to the power of n minus 2, which is equal to 0.5 to the power of n. Okay, so we'll try solving this and we'll find out what is C. So you have C into n into 0.5 to the power of n minus 0.9 into Cn minus C into 0.5 to the power of n divided by 0.5. Okay, I'll split that. I'll write 0.5 to the power of n into 0.5 to the power of minus 1. That is 0.5 to the power of n by 0.5. Plus I have 0.2 into Cn minus 2C into we have 0.5 to the power of n divided by 0.5 whole square, which is equal to 0.5 to the power of n. Understood this one, this step everyone? Have substituted what is this yp of n minus 1, yp of n minus 2, and I'm trying to get common terms 0.5 to the power of n on both LHS and RHS so that they will cancel. Okay? Clear? Is it clear?
Yes, ma'am.
Others is clear?
Yes, ma'am.
So now we can take 0.5 to the power of n common, right? It is common to both LHS and RHS, so it will get cancelled. So we can cancel out this 0.5 to the power of n, both the sides. So if we cancel out that on both the sides, common to LHS and RHS. So you have Cn minus 0.9 into 0.9 by 0.5 into Cn minus C so you have 1 minute. So you have Cn minus 0.9 by 0.5 into Cn minus C plus 0.2 by 0.5 whole square into Cn minus 2C which is equal to 1. Correct? Followed?
Yes, ma'am.
So now we will
Ma'am, can you
we'll
repeat
try
that
to.
line, ma'am?
Yes.
Can you repeat that line, ma'am?
This line, okay. So what we are doing is I'm trying to, we have these equations yp of n minus 1, yp of n minus 2. Okay. So what we are trying to do is I'm trying to take 0.5 to the power of n so that it will cancel off. So I have Cn into 0.5 to the power of n minus 0.9 C. So I'm multiplying this also. Cn minus C into 0.5 divided by 0.5 to the power of n divided by 0.5 plus 0.2 into Cn minus 2C into 0.5 to the power of n divided by 0.5 whole square, which is equal to 0.5 to the power of n. Because we are trying to take common terms for LHS and RHS so that we can cancel that out. So if I cancel out this everywhere, 0.5 to the power of n is common to all LHS and RHS. So it will get cancelled. So what remaining terms you write it here? Cn minus 0.9 by 0.5 into Cn minus C, because this is cancelled, plus 0.2 by 0.5 whole square into Cn minus 2C is equal to 1. Clear? It's clear? Now what we will do is I will multiply these terms with Cn and C, Cn and 2C. So I have Cn minus 0.9 Cn by 0.5. Yeah. Plus I have 0.9 C by 0.5 plus 0.2 Cn by 0.5 whole square minus 0.4 C by 0.5 whole square, which is equal to 1. Got it, everyone? I have just multiplied this with this. 0.9 by 0.5 Cn plus 0.9 C by 0.5 plus 0.2 by 0.5 whole square into Cn minus 0.4 by 0.5 whole square is equal to 1. Got it? Clear?
Yes, ma'am.
Now you compare the constant term on both the sides. Okay? So this and this we can equate it to 1. So we'll compare the constant term, C term, on both the sides. So we have 0.9 by 0.5 C minus 0.4 C by 0.5 whole square, which is equal to 1. So what do we get? You solve this, you get 1.8 C minus 1.6 C is equal to 1. So you have 0.2 C is 1. So C is equal to 1 by 0.2, which is equal to 5. So we have got C as 5. Understood? It's clear? Clear, everyone? We are just taking the C term and equating it to 1. Because we have to find C, right? So we'll take the terms with C and equate it to 1 so that we'll get C. Got it? So your C is given to be 0.5, right? It is given to be just 5. So your particular response will be Yp of n, that is equal to 5 into n into 0.5 to the power of n. So Yp of n is equal to C into n into 0.5 to the power of n, right? So that was 5 into n into 0.5 to the power of n. So we have found out particular response. Now we'll find forced response. So forced response, Yf of n is equal to Yn of n plus Yp of n. Okay, so that you will have what is natural response. So Yf of n would be equal to K1 into 0.5 to the power of n plus K2 into 0.4 to the power of n plus 5n into 0.5 to the power of n. Now assume zero initial conditions and find out K1, K2. Are you guys following? It's clear?
Yes, ma'am.
So you take Yf of minus 1, wherever you have n, put minus 1. Yf of minus 1 will be equal to K1 into 0.5 to the power of minus 1 plus K2 into 0.4 to the power of minus 1 plus 5 into minus 1 into 0.5 to the power of minus 1, which is equal to 0. This is your equation 3. Next you take n is equal to minus 2. So Yf of minus 2 will be equal to K1 into 0.5 to the power of minus 2 plus K2 into 0.4 to the power of minus 2 plus 5 into minus 2 into 0.5 to the power of minus 2, which is equal to 0. Because while finding the forced response, we'll assume 0 initial conditions. So I have put 0 and 0. Previously, they have given you 1 and minus 4. We have used that for natural response. That is fine. When you are finding forced response, assume 0 initial conditions and find out K1, K2. So now you solve for K1, K2 and tell me what you will get. Did you guys follow? Is it clear till here? Understood why we equated it to 1? Because it is n to the power of 0. N, this is n terms. Cn, this is 0.9 by 0.5 Cn. This is 0.2 Cn by 0.5 whole square. You have n terms here. If you have n here, you can equate those to this. But you have 1 here. So yeah, it is n power 0 is 1. Right? So we have equated this to 1. Wherever you have just C. Wherever you don't have n. Got it? Then we have to find C and we'll find particular response. Then assuming 0 initial conditions, find K1, K2. What is K1, K2?
Ma'am, 5 and 0.
Minus 15 and 16, ma'am.
Minus 15 and 16?
Yes,
Check
ma'am.
it
Minus
once.
15 and 16.
Yes, you will get minus 15 and 16. So your YF of n will be equal to minus 15 into 0.5 to the power of n plus 16 into 0.4 to the power of n plus 5n into 0.5 to the power of n. This is forced response. We have found out that. Now we'll try to find a total response, which is y of n. It is equal to yn of n plus yf of n. Okay, so what is the natural response which we have got? Previously, we have got 6.5 and 4.8, K1, K2 in natural response. So it is 6.5 into 0.5 to the power of n minus 4.8 into 0.4 to the power of n minus 15 into 0.5 to the power of n plus 16 into 0.4 to the power of n plus 5n into 0.5 to the power of n. Whichever is you can solve it, you solve that. This you can solve it and you can solve this. And tell me the final answer. So y of n, that is total responses, 6.5 minus 15. You will get minus 8.5 into 0.5 to the power of minus n. And 16 minus 4.8, you get 11.2. Okay, plus 11.2 into 0.4 to the power of n plus 5n into 0.5 to the power of n. For n greater than or equal to 0, or multiply this whole equation with u of n. Got it, everyone? Clear? Is it clear?
Yes, ma'am.
Okay, so we one more problem I'll give you. Homework, you try that. Okay. So that's all for difference equations. You have to solve like this. Both are the same. You have to find the total response by finding natural, particular, and forced response. You take down this problem and try solving. So y of n is equal to 0.5 y of n minus 1, which is equal to x of n, where x of n is equal to n into 0.25 to the power of n into u of n. And initial conditions given is y of minus 1 is equal to minus 1. This is the given first order LTI system difference equation. Okay, y of n is equal to 0.5 y of n minus 1, which is equal to x of n. X of n is the input, which is given to be n into 0.25 to the power of n into u of n. Okay, and your initial condition is given as y of minus 1 is equal to minus 2. Sorry, minus 1. Why only one initial condition is given? Because this is first order only. Okay. Previously, we have got second order equation. So, we have two initial conditions. That is, we have y of n minus 2 term also in the equation, difference equation. This is first order, so you have only one initial condition. Will you try solving or you want me to solve now?
Ma'am, that is y of n minus 0.5 or equals to 0.5.
Y of 0.5 into y of n minus 1.
Before that, ma'am, y of n equals, ma'am, that is.
Which one? Previous sum or this one?
This only, ma'am. What is the question, ma'am?
So the first order LTI system is given by this differential equation. That's all. Y of n is?
Ma'am, I am asking what you have written, ma'am. Y of n after equals or minus?
Equal to 0.5 into y of n minus 1.
Yes,
it is equal to symbol. Y of n is equal to 0.5 y of n minus 1. So what will you get the difference equation? Y of n minus 0.5 y of n minus 1 is equal to x of n. Correct? Got it? Clear? One minute, I'll check that. It's equal to or minus. It is minus. I am sorry, it is minus. Y of n minus 0.5 into y of n minus 1 is equal to x of n. You want me to solve or you will solve this? Tell yes or no.
Yes, ma'am.
You want me to solve this? Okay.
Yes, ma'am.
Okay, we'll try solving this problem. So, the characteristic equation you take. This is a given difference equation. You have to take the characteristic equation. Okay. So, that will be 1 minus 0.5 z inverse, which is equal to 0. Okay, this is your characteristic equation. If you multiply this with z, some variable, so you have that z inverse, you can take anything. Okay, so I have just taken z here, this variable. So you will have z minus 0.5 is equal to 0. So z is equal to 0.5. This is one root of the characteristic equation. So it is real and distinct. So your natural response yn of n will be equal to k1 into 0.5 to the power of n. Okay. Now, making use of this initial condition, find out what is that k1. So you put yn of minus 1, which is equal to k1 into 0.5 to the power of minus 1 and equate it to minus 1. So what will you get? K1. What is K1? K1 by 0.5 is equal to minus 1. So K1 will be equal to minus 0.5. Yes or no?
Yes, ma'am.
So now we have got what is K1. Your natural response Yn of n will be equal to minus 0.5 into 0.5 to the power of n. Okay, this is your natural response. This will add it with the total response at the end. Now we'll find a particular solution or particular response. So they have given x of n, right? They have given your x of n to be equal to n into 0.25 to the power of n into u of n. That is n into 0.25 to the power of n into u of n. Okay. So what is the structure of your particular response? Yp of n. It is of which form? Check that in the table which is given. So n into alpha to the power of n. Yes or no? Your input is of the form n into alpha to the power of n. What is the structure of particular response? It is alpha to the power of n into C naught plus C1 into n. Got it? You check the table. Yes or no? If input is of the form n into alpha to the power of n, your structure of particular response will be alpha to the power of n into C naught plus C1 into n. Clear?
Yes, ma'am.
Now your particular solution Yp of n will be C naught plus C1 into n into 0.25 to the power of n. Yes or no? Now we have to find the constants C naught and C1 by substituting in the difference equation. Okay, so you need Yp of n minus 1. So if you put n is equal to n minus 1, you will get Yp of n minus 1. So that you can put that in the difference equation which is given in the question. So Yp of n minus 1 is equal to, it is C naught plus C1 into n minus 1 into 0.25 to the power of n minus 1. Okay, this is your Yp of n minus 1. So your difference equation was like this, right? Yp of n minus 0.5 Yp of n minus 1, which is equal to n into 0.25 to the power of n into u of n, that is 1 u of n. So if it is like this, now we substitute this one here. This is C1. Yeah. Substitute Yp of n, that is C naught plus C1n into 0.25 to the power of n minus 0.5 into C naught plus C1 into n minus 1 into 0.25 to the power of n minus 1, which is equal to n into 0.25 to the power of n. Okay. So now what you will do? Next step. I have put what is Yp of n and Yp of n minus 1 in this difference equation given in the question. So now let us try to cancel out this 0.25 to the power of n on both the sides, LHS and RHS. For that we will do one modification. So C naught plus C1n into 0.25 to the power of n minus 0.5 into C naught plus C1 into n minus 1 into 0.25 to the power of n divided by 0.25, which is equal to n into 0.25 to the power of n. Now you can cancel out 0.25 to the power of n on the both sides, LHS as well as RHS. Okay, you cancel out that, and what equation will you get if you cancel that? Are you guys following what I'm doing? Is it clear?
Yes, ma'am.
Yeah, now you solve this. Okay, so after you cancel out 0.25, what do you get? So you have C naught plus C1 into n minus 0.5 by 0.25 into C naught plus C1 into n minus 1, which is equal to n. So if you solve this, you get 2. So you have C naught plus C1n minus 2 C naught minus 2 C1 into n minus 2 C1 is equal to n. I am just multiplying that with 2 and I am splitting this. C1 into n minus C1, I am multiplying it with 2. Got it, everyone? Now, how will you find C0 and C1? You have n terms here, C1n, 2C1n and n. Compare the coefficients of powers of n. Okay. So you have C1 plus 2C1 is equal to 1. Correct? N, wherever you have n, that terms I am grouping, which is equal to 1. That is C1 plus 2 C1 is equal to 1 I have put. Then other terms, wherever you don't have that n term, that I'll take here. C0 minus 2C0 minus 2C1 is equal to 0. To solve this, we need C1. So what you get? This is minus 2C1. Understood what I have done? We are comparing the coefficients of power of n. Got it? Clear? Is it clear, everyone? C1n minus 2C1n is equal to n. N gets cancelled. You have C1 minus 2C1 is equal to 1. What we are doing is we are comparing the coefficients of power of n, like we have done in previous problem. Okay, and C0 minus 2C0 minus 2C1 doesn't have n term, so we equate that to 0. Okay, so what is C1? Minus C1 is equal to 1, so C1 is equal to minus 1. So substitute that C1 in that to get C0. Following?
Ma'am, I think plus 2C1, ma'am.
1 minute. Where?
Ma'am, in equation C0 plus C1n minus 2C0 minus 2C1.
Minus you are multiplying, no?
Yes, ma'am, minus into minus plus, no, ma'am.
Yeah, that will be plus 2C1. Thanks. Now you solve it. What you will get C1? Minus C1 will be equal to 1. C1 is equal to minus 1. So what is C0? You have minus 1 C0 plus 2 C1 is equal to 0. So minus C0 plus 2 into minus 1 is equal to 0. So C0 will be equal to minus 2. Got it? Clear, everyone? We are comparing the coefficients of power of n. Got it? Clear, everyone, this step? Till here clear?
Yes, ma'am.
Others clear? Everyone?
Yes, ma'am.
So your yp of n, it is of which form? It is of the form C0 plus C1n into 0.25 to the power of n. So what you will get? C0 we have found out and C1 also we have found out. So it is minus 2 plus minus 1 into n into 0.25 to the power of n. Okay. So that would be minus 2 minus n into 0.25 to the power of n, or you can also write it as minus of 2 plus n into 0.25 to the power of n. Got it? Particular solution? Everyone? Clear?
Yes, ma'am.
Now you find the forced response. Forced response is yf of n, which is equal to yn of n plus yp of n. So it is k1 into 0.5 to the power of n, which we have solved it previously. That is of natural response structure. Okay, that is only one we got, 0.5 characteristic equation. So we have to find k1 assuming 0 initial conditions. Minus of 2 plus n into 0.25 to the power of n. So now assume 0 initial condition and find out what is k1. So yf of minus 1 would be equal to 0. That would be k1 into 0.5 to the power of minus 1 minus of 2 minus 1 into 0.5 to the power of minus 1. Equate that to 0. And you tell me what is your k1. You have k1 by 0.5 minus 1 by 0.25, which is equal to 0. So it is k1 by 0.5 minus 4 is equal to 0. k1 by 0.5 is equal to 4, I will write. So k1 is equal to 2. Okay, this is your forced response. That is yf of t is 2 into 0.5 to the power of n minus 2 plus n into 0.25 to the power of n. This is your forced response. Now total response you add it, forced and natural. Sorry, this is yf of n. I am sorry. It is yf of n. So you have total response y of n is equal to y natural response plus forced response. Okay, natural response, what it was, I told you guys to remember now. It was minus 0.5 into 0.5 to the power of n plus you have 2, that is forced response. Okay, 2 into 0.5 to the power of n minus 2 plus n into 0.25 to the power of n. You can solve this, right? This and this. So you will have 1.5 into 0.5 to the power of n minus 2 plus n into 0.25 to the power of n. Got it? For n greater than or equal to 0, or multiply that with u of n. Understood, everyone? Is it clear? Is difference equations clear, everyone?
Yes, ma'am.
What about others? Clear? You have any doubts?
Ma'am, we have to write into u of n, right, ma'am?
Yeah, into u of n you can write, or you can write n greater than or equal to 0. Clear, everyone?
Yes, ma'am.
Followed? You guys have any doubts? You have any doubts? Clear, everyone? Difference equations and differential equations? You can practice problems on this. Okay, this is there for your internals. Difference and differential, you have to know the procedure. If you know the procedure, it's very easy to solve. So you practice these problems. Tomorrow I will start Z transforms. Don't miss tomorrow's class. I'm starting unit 5, that is Z transforms. If you have any doubts, you can get it clarified, or you can write your name and US in the chat box. We'll meet again tomorrow at 8 a.m.
Ma'am, we have Kannada class, ma'am.
I spoke with your Kannada ma'am. She told to take.
Okay, ma'am. Fine. Thank you, ma'am.
Thank you, students.